Okay then, my name is Philippe Oechslin. I work with Objective Security in Gland, close to Geneva. I also teach at EPFL in network security. What I want to present today is something about EV certificate extended validations, the one which are green on the address bar. This comes from a teamwork. We had to audit a customer of ours this spring, and they were using EV certificates, and we had to implement all possible types of attacks and try to see if we can or not and how far it is possible to attack those certificates. And then we thought that might be an interesting presentation for you guys in the sense of what Chris said this morning, like we want to teach and learn, not just to break everything and drop bombs on castles or so. Some of that has already been published in other places, but I think the way it's put together and some things we put in here are quite original and will still be quite interesting for you. So what are those EV certificates? This is really something magical. If you look at the internet, you can see that because of those EV certificates, you can have 58% more revenues per transactions, and you can have 41% more sales. This must be really an awesome technology, as they say. Right? This is powerful. And those guys, they make 31% more sales with the very size seal, but then they added extended validation and have yet another 13%. So this must be really something absolutely crazy. So what is that? If you go and look it up, what those EV certificates are, technically it's a certificate that will make your address bar turn green. So it gives you more trust into that website. You like the green color and you feel more inclined to buy the stuff on the website, apparently. So there's a difference between EV certificates and DV certificates. We're going to make the difference all the time. DV means domain verified. To receive one of those are the classical certificates that we used to get before EV was invented. They were expensive in the beginning and then cheaper and cheaper, and now you can even have them for free. And the only thing you have to prove to get one of these is that you own the domain. So if you want to create a domain which is ubsebankinghackers.com, you register that domain, you create the email address, and then you can buy a certificate. They will send an email to that address to admin or webmaster or something. If you can prove that you received the email, you get the certificate. So they thought this is not very nice, we should have something which is safer, and this is why they introduced the EV certificates, the extended validation. Extended validation, which means the certification authority has gone to a great length to try to validate that you really are who you think who you want to represent. So if you say, yeah, I'm UBS banking or so, you have to prove to a lawyer that you actually represent the company called UBS or UBS hackers or whatever, if that was existing, right? So because now there is a strong proof that you really are that company, it is supposed that phishing will be much more difficult. We'll discuss that in the end to see whether that argument actually makes sense or not. But what we want to see is technically how this will work. And so we have that in all modern browsers. When you go to VeriSign, to PayPal, to whatever, you will see that it is green. Hashtags doesn't have one of these. So you should be careful if you go to the website of Hashtags. So who created those certificates? This is a consortium of the certification authorities on one hand, and of the browser developers on the other hand. They put themselves together and they call this the CA Browser Forum. Microsoft, Google, Mozilla, and VeriSign and all the other guys on the other side. And they said an EV certificate will have the following properties. In the normal entries of a normal certificate, you will have the things like the common name. These are things which are part of standard attributes, but you don't always have them on the certificates that you buy. If you want to have an EV certificate, you must fill in all those options. And one is, for example, jurisdiction of incorporation, state or province name. This means your company, the company you want to represent, that must be registered in some country, in some place, in some jurisdiction. So we want to know, is this a Swiss company, is this a company from the Bahamas or whatever, so that we know where we can go and check in the registers or whatever that you are the right company. So you have to fill in all of that information. And then you need also to have some of the extensions of certificates. One being the most important is the policy identifier. every certificate which is issued is issued according to a certification policy. I mean, I could open a certification authority tomorrow, and I could say, I give certificates to everybody, I don't care, and my policy would be, I give certificates to everybody, and we would have a code number which says this is a very, very simple policy, and then you have the normal policies where you do some checking, and you have a special EV policy which has some numbers, we'll see that in an example later, which says this is a certificate which uses that policy of extended validation. And then you need to have further information, you need to have a CRL distribution point, for example, so that people can go and see if a certificate was revocated, or a authority information access, which has the same meaning. It's just another technology where you can verify whether the certificate has been revoked or not, if it is still valid. You have to put some basic constraints saying this can never be a CA certificate. They don't give that away. They sign EV certificates, but you cannot sign other EVs with your certificate. And then some other extensions that you need to have. So this you need to have that the certificate is correct according to the forum, and probably also according to the browsers, because they're supposed to follow what the forum decides. So they should make that security is better because, first off, because they pay more attention when they hand out the certificates. And I have a friend who made a new company. He wanted to have an EV certificate. He didn't have a land phone line yet. He just had a GSM. They would not give him a certificate if they cannot call him and have him answer a landline. So he had to register a landline for a few months, so just that the lawyer could call and verify that his company actually exists and has a phone line. So this is one part from the certification authorities, and from the other part, the browsers must do some work to not be fooled too easily and believe that something which was not EV is EV. So you need to have some security also built in technologically into the browsers. And our question was, what we want to explore today, how easily can you fool a browser? I mean, you could also try to fool the other part, but from having seen what they do, it really seems difficult to do hypnosis. Did you see the presentation on hypnosis? Maybe you could try to social engineer them, and so that should be very, very difficult. What we want to know is technically, what is it actually that you need to do to break the system? And you can target two different places. You could say, well, I will insert a fake certificate in a computer, so somehow I have to own your machine to some point. I have a Trojan or something that will do something to your machine. That's one way of attacking. And the other way of attacking, we want to see, is by manipulating the traffic. Is it possible to do some man-in-the-middle attack and to do foolish things with your EV certificate? And we want to see that for two browsers, for Internet Explorer and for Firefox. So let us see first Internet Explorer. The way actually all of that is technically implemented is that we know how an EV certificate must look like, but it would be just too easy if everybody could just create EV certificates. So for a browser to recognize an EV certificate as being really EV, it must not only have all the parameters, it must also be signed by one of the CAs which is trusted to sign EV certificates. So in your browser, you usually have like 50 root certificates from different certification authorities. Not all of them can create EV certificates. Only like a group of, 14 or 11, I don't remember the number. They have agreed to pay attention and do all of that. And so you must have that list somewhere. And that list for Internet Explorer is actually downloaded by Windows itself through Windows Update. It will regularly go and check if there's a new list that came out and download that list. And in this list, you will have all the root CA certificates of the root CAs which are allowed to create EV certificates. And that list will be signed with the key of Microsoft. So there you have tough luck. Probably it's going to be very difficult to insert something in that list. And because we need to have a certificate which is signed by one of those CAs, it's going to be difficult to make a fake certificate, right? Sorry about that. So Windows downloads this list, verifies the signature, and now what is special about those root CAs? They don't have a parameter that says this one is a EV certificate. because if there was something like this, maybe you could just change that. What they do is it's a meta information about the certificate, which says this certificate is an EV certificate of an EV root, and that information is stored in the additional attributes of this EV root certificate. Now the interesting part is what happens after that. So it downloads every now and then when there's a new list. If somebody else starts doing EV certificates, the list will change, you get the new list. And what happens is all the certificates are taken from that list, the signature is verified, and then all certificates are put into the certificate store of Windows. And the information that this is a EV root is added into the environment, into the parameters of each of those certificates. And there is no signature anymore. Oops, we forgot something, right? So this is a typical case of time of check and time of use. Time of check, when they download, they verify everything, signature okay, you can't fool anything. And then, okay, we put it in the search store and we just leave it there, and there's no way of validating afterwards that it's actually a valid root. So if you want to attack that, the trick is like this. Oh, here we're saying the same thing again. So it verifies only when it downloads. But when you are using Internet Explorer and you go to a website, it doesn't look at the signed list anymore. It just looks at the certificate store, whether the root is there and whether it has this parameter that says this is one of the good roots. And moreover, this is a funny thing with IE. If you forgot to put the parameters about online verification, the CRL or the OCSP point, it will not check. This is not according to the standard, right? We see with Firefox you cannot create a certificate like that. But the funny thing is, if you don't have that, it will not test, and then you could have a certificate which has been revoked, and you'd have no way of verifying. Present. We'll see Android security afterwards, so we'll see if this is a problem. So how would you attack Internet Explorer? First of all, you create your own certificate. You add those parameters about EV, so you say the policy is an EV policy. You say, oh, there's no CRL, no OCSP, so IE will not check online if the certificate is still valid. Then you have to sign it with a root. You take your own root certificate, you sign that EV certificate. Now you just have to insert that root certificate into the search store, and now you have to set the parameter in the certification store to say that the property of this root is one of these EV properties. So you take the EV policy, you can copy that from another certificate which has that, and you do a cert set certificate context property, and you add the policies property of EV policy to that certificate. That's all. That's just a system call. You can do that, and your certificate will now be recognized as being one of the valid roots, and your certificate, this one, will then be a valid EV certificate. So let us see if you can do that. That would be Windows. So on this side, IE. Here. We've made a small program, so let me show you. There's a small kit to do that automatically. I have it in temp somewhere. We'll try to break PayPal to create a fake PayPal certificate. Let me first go to the real PayPal before we try to hack it. There we go. So we've all been there, probably. So it comes up green because it's an EV certificate and it's signed by a root which we trust. If we look at here, we can say VeriSign is the root which signed the certificate. VeriSign is one of those roots, and the company is PayPal Incorporated in San Jose, California. So far, so good. We can even look at the different information of the certificate. We will see at some point from which authority it was signed. It was signed by the Extended Validation SSL-CA of VeriSign. Okay, now we'll close that so it doesn't cache anything. And we'll try this small attack script. Let me show you what it does. It will use certutil, which is a small utility, to add into the store, into the root store. I'm an administrator, I can do that. If not, I will do it into the user store. I can insert the objective security routier into the store. I will do a redirection of the traffic to my own traffic, so I change that into the host file. I could be in the network somewhere, I could be doing some spoofing. For the demo, this is much easier. And then I will use that small program. Remember the command I showed you on the last page? We add that property to the certificate to say this is part of objective, this root CA, objective security root CA is one of those EVs which were supposed to be in the list. So let us execute that. Actually, I'll start this one. I'll tell you why just afterwards. So now we go back to IE. We try to go to get it. Now tonight, PayPal called us and they said we need your help, so we should do a venture together and make a combined company. So as of today, we're called PayPal OS, and our logo is all over the site of PayPal. And we see that this is a green certificate, so the browser believes that this is a EV certificate. It's been signed by Objective Security Root CA, and the company is Objective Security PayPal in San Jose, California. So we can fool anything. It's our PC, we do what we want, so we could do whatever. But now, so we have the wrong certificate. This is not the original one. We could have been more subtle and write exactly the same information in there, right? So you wouldn't see that. It's just for demo that you write Objective Security all over the place. But we could just write VeriSign, so you would really not see a difference. How could you still verify that this is not the correct certificate? How would you go about trying to find out if this is really the one of PayPal or not?
Checking the hash values of the CAs, no?
Yes, good idea. So is anybody online? Can anybody tell us the... No. Oh, you. No, yes, you. Can you go to PayPal and then try to see on the certificate if you have on the details the fingerprint of that certificate.
Which one are you looking for? The SHA-1 fingerprint?
Yeah.
Starts with 7814. Yeah, that's exactly that one.
Oh, it's the same one. Hey, we have a collision. Isn't that great? So we find the SHA-1 collision. So you all heard about MD5. We now have something new. We can do SHA-1 collisions. We have exactly. Well, we only see the beginning. Maybe the rest is different. No, this is just a joke. I told you we started a small program. This is an auto IT script. It will wait until that window pops up. And then it uses DJ Stevens' very fine process exploration toolkit. And we go into the memory of that process and we verify, we change the fingerprint with the other one. And so you can navigate here. It's been patched, so whenever you come back, it shows you the patch value. So there's no way you can check. Because the customer we had, they said, yes, but for our specific application, we send a paper sheet with the thumbprint of the fingerprint of the certificate. So people will know if you use another certificate. Well, no. If you hack the machine, they will not know.
Can you look at the certification path? The root?
Yeah, that would be wrong. Because we go. This one is signed by. We could have put all the names here. We chose to put Objective Security all over the place, but we could have said this is VeriSign, this is VeriSign. But then if you went to go, I mean, it's even faster. What you can do is the key actually, the serial number I think is also wrong. And if you look at the actual key, the key is also not the same. But see, if you let me hack your machine, I can change whatever I want. So I can make it just look like the real one, right? It's actually not unexpected. It's funny, but not unexpected. So that's the way how Microsoft implements it and how you can actually break it.
Is there anything wrong with this implementation?
Let's see the other one, and then we'll compare, and then we'll know what is wrong here. I mean, basically,
Microsoft will not solve the problem of if somebody is root on your machine,
No.
they can do something to you.
no, but they could at least solve the problem. I'm administrator right now, but I wouldn't need to be. As a user, I can do the same trick. With Firefox, and if I can root your machine, I can do many bad things anyway, and they can't solve that. But at least they could do a better effort to make it a little more complicated. But it's not going to make the problem go away, definitely not. And I think this is the main problem of all those EV certificates. It's supposed to do something which is just not possible. So they try to do a half-baked solution, but there's always going to be a way to get around it. So let us see what they could have done if they did it a little bit more difficult.
But isn't another problem of PKI in general, that the software vendor is setting the trust for you?
Oh yeah, you install Internet Explorer, you have all those rules. You have, from all the countries, there's a root that you're supposed to trust. Yeah, that's a big problem with PKI in general, definitely. Definitely. Let me just come back to what we saw with IE. So it is sloppy. They could have done it better, but they could not have prevented that we change everything if we hack the machine, but at least they could have verified at surf time and not when they download the roots. That would have been more clever. They could have prevented that we can do the manipulation without admin rights. That also, if you insert a certificate and you're not an administrator, there's going to be a pop-up that says, do you really want to insert that certificate? But you can suppress that pop-up in the same way that we manipulated the other windows. So there's tools that do that already. So, and something else they do, which is sloppy, they do accept EV certificates which don't have all the EV parameters. Now they are in that forum, they discuss of all those parameters, they could have done a better job. We didn't have to put the business category, jurisdiction, province name, and country name. All those parameters you don't have to put in there and it will still be accepted. When we did the same work with Internet Explorer, we spent a lot of time putting everything correct until it would take that certificate. Here you just need the basic information. If you omit the rest, it will just be happy and accept it as an EV certificate. So how does Firefox solve that? In Firefox, you also have a built-in list of root certificates. They are not downloaded, they are hard-coded into libNSS. You were talking about libNSS, right? This is shared by different Mozilla applications, for example. And when it's in the file libNSS ckdi.so, and whenever there's a new version of the library, there's going to be new certificates in there. You can't just update the certificate. There's no mechanism normally used for updating those certificates. This is the root certificates, right? All the root certificates, like the 50 that you have in your Firefox. And then you have a second file, libxul.so, which says which 14 or whatever out of the whole list are the ones which can sign EV certificates. So that's another file, and it's just like a pointer to which ones are used for signing EV. And both those libraries are signed. We didn't even care to check the exact mechanism, but what happens is the signature, like a binding, is done at compile time. So if you just exchange the library, Firefox will not run anymore. It will say this is not the same version, it doesn't work. You have to recompile Firefox for that new version of the library, of libNSS, if you wanted to use that version of the library. So what could we do? What are the verifications that Firefox will do? And here we see that they do much more than IE. So they will verify that the libraries have the same signature than Firefox when it was compiled. So you can't just change that. I mean, it's more difficult to change that. They will verify that the EV certificate is signed by one of the built-in roots, and that built-in root is in the other list, which says which are the EV roots. It will verify that you have all the EV declarations. So this is better than in IE. You have to put the OCSP or CRL or so. It will then say, it will then try to do the online verification, and that verification must not fail. So there's a little bit more work if you want to fool Firefox. So we implemented the attack in that case also. We add a root certificate in the library which has all the root certificates. We add an identifier in libxul to point to that certificate. It's actually just a structure which contains the certification policy. That's the one which says this is EV. That's the name of the policy, so this is the operative certificate EV OID. This one is not necessary, and here our script will replace with the fingerprint and the issuer in base 64 and the serial number in base 64 into the source code of Firefox. So you have to patch this part. You have to recompile Firefox, so that takes some time, and then you can install it on your victim's computer, and then you have to create a valid EV certificate which has a valid CRL, and you have to deploy to publish a CRL which says nothing has been revoked yet, so that the revocation test works, and then that's all. Then you can do the same thing again. So let us just illustrate that. If I show you so we made that for Linux. It would probably also work for Windows, or I'll put it on the, can you read that? If you want it larger, and is that better? So if you look at the files we have here, we have one make file. What we say, you need to have the whole Mozilla source tree. So you take the latest Mozilla source tree. You need to have that certificate that you're going to use to be the fake root. And then it will create a directory called Firefox, where it will put all the files which are necessary to run Firefox, all the libraries and executables and so on. And the only information it actually needs are 3 small patches, which will actually do the changes that we need. One is the, let me see, the Sec Manager patch changes the make file. When the make file creates the library, it will add some extra commands to add our certificate into the library also. And then you have also the one you saw before. In libxul, we add this part of text in the source code so that we have a pointer to the certificate we're going to insert. And actually, these strings here are going to be replaced using that Perl script. It will add automatically the fingerprint, so you don't have to copy that by hand. It's less work if you want to run that. So the only thing we need to do is make. I'm not going to compile now, it's going to take too much time. And then it will compile everything, it will create a version of Firefox in that directory, and you can just start that. You must first quit when you're running Firefox, because it will not reload actually the new one. And between the time I did that and today, I've upgraded my Firefox, so it's not the same version. So it says, oh, I have to check the add-ons. So it's not very stealthy. I would have to have exactly the same version for it to be stealthy. And then we could do the same thing. PayPal, and we see that we're still on the web page, and we have a green certificate. And if we go there, it will say, this is run by Objective Security at PayPal and has been signed by OS Objective Security. Blah, blah, blah. So it's the same thing. We didn't hack the fingerprints of the certificates. It could be done also. That's to show how far you have to go if you want to do it for Firefox. So that's the attacks you would do on the machine if you can install a Trojan. Now, what if you want to do man-in-the-middle attacks? We have no access to your machine, and still we want to play with those EV certificates. Here are different things you can do. The first one is, it's an interesting feature of the browsers. They could do better in that case also. If you are on an EV page, and that page downloads things from imports things from some DV sites, this will still be accepted. It will still be green in the bar. So actually, I don't have to hack the EV certificate. I can hack the DV one, the domain verified. This is easier. EV was here to add some security, but I can do with the simple DV security, I could still do an attack. So for example, if a web page includes JavaScript from the DV side, I can just do a man-in-the-middle attack on the DV side, and my attack will be executed in the EV web page. I mean, that would be crazy, right? To take if you go for EV, you should put everything in that place, right? So who would be foolish enough to include JavaScript from a non-EV site on their EV site? Have any ideas? Any? UBS? No? And who in their right mind would then go and tell everybody to do the same? No idea? No, not Google? Somebody who pushes these EV certificates? Not PayPal. VeriSign, yes, let's try VeriSign. Let me see, I just want to have my right Firefox, so I'm sure I'm not mixing two demos. So it's checking the modules again. Yes, we agree with that. So we're going to go to VeriSign. If it ever answers. No. They've seen that we're playing tricks, so they don't want to have us anymore. So we have the green bar, so we have the right certificate from the right website, but somewhere it's going to include some JavaScript from somewhere else. And we have redirected the traffic to that somewhere else to our website, and we have a DV certificate on that website, and we'll see what happens now. Maybe. Oh, that's not going to be fun because I have more of these. There's like tens of sites like this. Oh. See?
Recastle.
So you can hear it, right? Because on this webpage they say this was made with SSL certificates from VeriSign and they are very safe. And they have a little Flash player, and the code to execute that Flash player is actually taken from seal.verisign.com, which is not an EV domain. So if we say, is EV safer than DV? If we attack the DV site, we can attack the EV site. I mean, we're just showing a video for fun, but we could do anything in the page because our JavaScript code is actually executed. And I said they did that mistake, but they also tell everybody else to do the same thing, right? If you go to, I mean, we could try, but I think it's too slow. Let me just, if you want to have a concert of all of that. So we have the National Agency of, let's do just a few of them, so it's not going to be too long to load. So here, for example, here the security policy and the agency and blah, blah, blah. And here we have AC lenses. We had enough of that, right? But here we have that famous company, AC Lens. Remember, those are the ones who do 30% more sales thanks to EV certificates. When I tried this demo 2 weeks ago, it was red here. And why was it red? Because if you look at the contents of the site, all the media, there was one GIF somewhere which came from an HTTP site and not from an HTTPS. So they lost all their 13% from EV plus the 58 from VeriSign at all. And now, strangely enough, they don't have this EV certificate anymore. They use just a standard domain verified certificate. So even they, who make so much money thanks to that, don't believe in the system. So that's one way if the things come from different sources, and then you could have, if you were trying to be safer, you could try to have everything from the same origin. You say, I have an EV certified website, I load everything only from here. And here you can still play tricks. This has been done at Black Hat before, so we haven't invented anything. We were very proud to find that, and then very disappointed to know that many other people have already done that. But what happens is the browser is going to download the page, say the HTML document. It will display the green bar because this came from the EV site. And then on the document it says you have to download the GIF, the JavaScript, and blah, blah, blah. And if at that point you can redirect the traffic to another site, and that site is only DV certified, the green bar will still stay there. So you can have, even if everything was supposed to be on the same site, you can just do a deviation and then take it from somewhere else and include it into that web page. And the browser will be happy and show that there is absolutely no problem. So a simple case is where you have frames, but we don't find many customers anymore who use frames and who have EV certificates. Or if you include some JavaScript, you could try to redirect the traffic at this point. So let me see if we can get this to work. This is the more tricky demo because it doesn't work every time. So we have a small script, TCP break, which is an adaptation from something which already exists. which is TCP watch -script, where you can watch TCP connections and act on them. So what I'll do is from my Windows machine, I will redirect the traffic to that script. So I would be a man in the middle and do hop spoofing or whatever, but that's easier. On my host file, I have redirected the traffic to that script, and that script will let the first connection go to the original website, and then you know that browsers open like 4 or 6 connections at the same time. So any other connection will redirect to our website and get our modified content. We're not going to do JavaScript, just simple GIFs or so, just to show the demo, but nothing very clever. So I have to start that. That would be this. Oh yeah, this is I'm going to try the militarybankonline.bankofamerica.com. So I'll go back to my window in Firefox, standard Firefox, not modified. I have a shortcut, so I don't have to type it again, and go to the military bank online. And so we see we have the green logo, and here we have a funny creature which appears here because after loading the page, it's going to load the different GIFs. We were not lucky in this case because you only got this one. Usually, sometimes you also get this one. The way the browsers distribute their downloads on the different TCP connections is not always predictable. One thing that we tried is just cut the connection, and then the browser has to create a new one. But if it was in the middle of downloading something, like this logo, then it will display an error. So it's a bit tricky to find out when you can cut it. So we decided to let the first one open and just to redirect the other ones. We could try a second time, see if it works better. But you get the idea. We can change. We have to. Let's go back and see what the script has done. In the beginning, it has gotten a connection to Military Bank Online Bank of America, and it has forwarded that to Military Bank Online Bank of America. So the first connection was forwarded, and then it served a lot of data on that connection. And then at some point later, we have a second connection which opens, and this one is forwarded to an IP address which is under our control, where we have the fake site which serves the fake GIFs. So let me just try once more. And no, but still we have it here. So you see the idea. So you make a complete copy of the site on another website, and then you know some elements. The further we go, the more elements are going to be taken from our copy, and we can then do what we want on that website. So, what can we conclude from all of that? What does the green bar actually really mean? If your machine is compromised, it means nothing. But we all knew that, right? That was the remark. If I can hack your machine, I can do whatever, any green bar, so it doesn't mean anything. If your machine is clean, it means that some part, initially, of the web page you're looking at came from the original site of that company. And that company proved to a lawyer that they really represent the company which is on the certificate. But just some parts, all the rest we don't know. This means that if I can break DV, I can also break EV. So actually EV is not stronger than DV. I mean, it's just the first part which comes from the DV, from the EV side, the rest I can do what I want with it. So if somebody wants to do attacks on DV certificates, they can also do them on EV. Now, I make it look like very simple because I had a redirection in my host files and I have an exception in my certificates, so my browser doesn't care about that. But actually, SSL, HTTPS is very safe. It's very difficult to really carry out an attack without being noticed, without having this big alarm which says, this is dangerous, do you really want to do that? The only way you can do that is if you can control the certification authority, and if you can control the traffic, so you can deviate the traffic and produce a certificate which is valid. But this can be done, not by myself, that's difficult, but some governments, for example, if you look at what they do in India or the United Arab Emirates, some governments say, we want to be able to intercept BlackBerries, for example. Well, the United Arab Emirates, they certainly have a national internet provider, so they could send the traffic wherever they want. They probably have also maybe a root CA which is in your browser. They don't even need that. If they can just redirect the traffic to get a DV certificate, you just have to prove that you can receive an email. So if you buy a certificate from a CA where the traffic has to go through your network, you could just do some DNS spoofing, some rerouting, whatever, you will get that email and you will be able to register that certificate. So you can get a fake certificate, you can redirect the traffic. So if you're in one of those countries, you can have the green bar and they can still see what you're doing on PayPal or wherever. So that's what it actually does, and what can we learn from all of that? What are the lessons most of that, if you look around, you'll find also at some other places. What we took away from that is that from comparing the Mozilla stuff I've never seen somewhere else. So from comparing both of that, you can see that Mozilla does more work than ID to verify. So that's a good practice. Certainly should be a good idea to do that. In Windows, a simple user space program could do the whole trick. On your Linux, it depends on how you install your Firefox, if you install it in user land or if it's installed and all the libraries are installed with root rights. What we also see is that there's a problem with the browsers, and this is something where we were also very surprised. I mean, you've seen all those pop-ups when it says you have some encrypted and non-encrypted stuff on your website, you have this, you have that. Why don't they have something like this when you have a mix between EV and DV? And they would say, oh, this seems like a EV page, but some content has not been verified. That would be a good idea. That would make the attacks a little more complicated.
Have you reported that already to Mozilla?
No, not yet. But for Mozilla, there's nothing. I mean, no. We could. We should. Yes, we should. But we haven't yet. No.
Would be good, no?
Yeah. I think they know. I think they have a reason. But we'll report it anyway. But I think the plan is probably different. Yes.
How many? What's the percentage of EV sites that has EV parts?
Which has both types of parts.
Items that are served by DV servers.
I don't have a number on that, but I would expect almost all of them, because they're made by web designers and they take their JavaScript from different sites and they combine all these things. If you start telling them you all have to have it on the same server, they just say we can't do the fancy design anymore.
But then you have then you lose your baseline in terms of users expecting a green bar instead of maybe like a yellowish green bar for a warning. If all they see on every site they visit is a yellowish green bar, for example, then they'll just accept that.
Yeah. So, and that's a fundamental issue. There's no way we can add more trust with just putting some color somewhere. We have either to change the way we do the sites, and even in that case, it doesn't. And it's even worse than that. I mean, it's something we have sometimes have problems like that. It's for the good guys to do the good things, but it doesn't prevent the bad guys to do the bad things. If I know that PayPal has green and UBS has green and whoever also has a green bar, but then I go to Credit Suisse and it's blue, I'm not going to be scared. It's not like I expect everybody to be green. If really everybody expected everything to always be green, and green really meant something better, then when you see something which is not green, you'd say, oh no, I'm not going to buy anything from here. This is a phishing site. But it's just not the way it works. It would have to be everything is green, and actually they would have to stop selling DV certificates or something like this. It's just it just doesn't work this way. You can't. If you have an EV certificate, you can just prove that the person who asked that certificate proved that they are really that bank. But then you're already at the good guy when he proves that he's the good guy. What you want is when you're at the bad guy that it says this is really a bad guy. And there's no way of proving that the bad guy is a good guy. You can only prove that the good guy is good, and then you'd have to have all the good guys always having green certificates so that you could recognize the bad guys. So it really doesn't help. And maybe this also explained this thing that they don't actually really care. See, I mean, this company that did all those more sales and whatever, they don't even use EV anymore. VeriSign themselves use JavaScript from DV sites. I mean, if they wanted to, if they really thought that you could do something really strong with it, they probably wouldn't treat it this way.
Have you checked online banking sites for this DV-EV mix?
No.
Isn't there a company or a CA that is selling EV certificates, or not even selling them, or for free, like not really checking thoroughly?
I don't think so. I think
Well,
that,
I think I read something a couple of
But not
months
EV,
ago.
that's not EV.
and there might be DV. There were some of them, in DV they should verify it by sending an email, and some of them didn't do it. Or for example, when hotmail.ch came up, I registered webmaster at Hotmail. You can't register webmaster, they pay attention. But on some sites you could register webmaster at something, and then you can get a certificate for that service, for example.
That's the
So-
Israeli CA, right?
Yeah, they are very cheap. Is that Start SSL? I mean, the friend I have who bought this EV certificate, he paid like $125. And I don't know how they paid the lawyer to do all the phone calls and to call again and check everything for that amount of money. But
Well, big question is how they finance the web trust certification, because to get into the browser you need at least a web trust. A certification is called web trust.
yeah,
And
I don't know.
this costs
it's scary.
a
because-
couple $10,000.
Yeah, I think it's hundreds. To be in
Hundreds.
Microsoft, I think that the price is like 500,000 to do all the certifications and all to prove that your CA is handling everything. You get audited by whoever, and then you prove that you do everything right.
Well, it's roughly $1 million Swiss franc if you want to get the Swiss certification. That is.
Yeah, I know that. Yeah, but that's even more because that's for legal signing.
Yeah.
Getting into a browser.
What I need to
is-
get into the trust anyway.
Yeah.
Because this is equal to the ITSI.
And so all these people pay so much to some very strong security, and then you get all these free certificates and stuff that doesn't really work. Somehow it's scary, but I don't think this is a right way of making it better.
Have you tested to fake the or to send in fake documents to a registration authority?
No.
Because I think the weakest point of the whole system is the registration authority.
That might be. There have been Microsoft certificates who have been delivered to somebody else than Microsoft. I told you just in the beginning of the slide, we did the technical test. We could have done the social engineering test to try to fool the lawyers, to tell them that we are UBS, even if we are not UBS. Because
Two guys, we had to run an RA in Switzerland. And I can only say it's really difficult to check all these documents because you are not trained in doing that.
Mhm.
You're not a police guy who knows what is how to
valid-
check an ID
Yeah.
copy, stuff like that. So I guess it's pretty easy to fake.
But in that case, the Israeli guy had to call a Swiss lawyer, and the Swiss lawyer had to say, I verified that this company is a real company. Now, how the Israelis know who are the right Swiss lawyers and who are not, I don't know. Maybe they have some forum where they exchange how they authenticate themselves, and it's a recursive problem. There's no right solution. So I think time is almost over, but just the last bit. The lesson learned is don't believe marketing, right? I mean, 18% more sales, 58% more revenue. Never, ever. This is just marketing hype. Making more money, or I don't know, but it's certainly not more security. And if that was true, they would not have a blue certificate now. If they had a green one and that made so much money for them, they don't want to earn less money and change that. Right.
The numbers are probably true for VeriSign though.
Oh yeah.
Adding one more color to the bouquet.
Exactly. The green pixel, they can sell them very expensive. So the last slide is just some references. So the guys from Kion in Switzerland, they already had something in 2007 where they explained how it works in Internet Explorer. We still had that when we did our work. And Breaking Security Myths, that's a presentation of Sotirov last year at Black Hat where they did all these rebinding attacks also. So if you want to know more about this, this is where you can go and have a look. So you have any questions? Okay, well, there's been many questions during your talk already, so let's go on. Thank you very much.